Hey everyone, so in this video we will continue with our exponential smoothing forecasting model, and we will now add also the trend to the forecast. So we have our forecast from the previous model based on our alpha and the level forecast formula. What we're going to do now is we're going to add a trend forecast using parameter beta. Beta is again between 0 and 1, and our final forecast will be basically the level forecast plus the trend forecast. So we can go ahead and get started. I'll just make some space here. And firstly, I will rename this to level forecast. And we will also have trend forecast here, which will be beta hat for period t. And then our final forecast using this formula here will be x hat for period t. Now, to set and initialize the forecast for trend, typically you would use 0, but I will show you how to set up and initialize the forecast slightly later with a more accurate value. And then our final forecast is basically the level plus trend. So we can go ahead and start with our updating procedures. So starting with the level forecast, we are using the same formula as in the previous video, but there is a slight modification where we are also adding the trend component at the very end. So instead of just multiplying this by a hat t from the previous period, we also need to add b hat t from the previous period. Since it's 0, it doesn't do anything, but it will change the values in the once we get the trend forecast here. Now we can go ahead and generate the trend forecast. So going here, we use parameter beta times our level forecast minus our a hat forecast for the previous period plus 1 minus our beta factor times our trend forecast from the previous period. Hit enter and we can drag it down to generate the forecast. You can see that the trend is capturing the forecast, and then the final forecast will be again just the sum of these two. Now, to initialize the forecast a little bit more accurately, we can use a linear regression to capture the trend that we are seeing in the historicals, which is typically recommended. So to do that, you can use this formula using linist, and we have known y's column here and known x's column here. Hit enter. So we now know what is our coefficient. It's 6.44, and this is our intercept. So we are just going to use the coefficient, and we will replace our trend forecast for the period 0 to get more accurate trend forecast initialization. That's it. We now have the forecast using level and trend. We can also do some accuracy comparison. So we can add the apps error column here, and we can just take a look at our absolute error. using this methodology. And we can also calculate our MAPE, or mean absolute percent error, which is basically just the absolute error divided by actual. And then our total MAPE will be just the average of the individual MAPEs for the individual periods. So our total MAPE is 3.28%. We can compare with the previous forecast as well. So I'm gonna again add ups error and MAPE column. So absolute error will be actual minus forecast, and our MAPE will be the absolute error divided by actual. And we can compare the two methodologies. Perfect. So you can see that using just level, our MAPE is 8%, while when we use level and trend, our MAPE reduced significantly to 3.28%. Thanks everyone for watching, and I'll see you in the next video.